Okay, welcome to our second day of oblique triangles. The topic for today is law of sines. Our essential question is, when do you use law of sines to solve triangles? All right, yesterday, last class, we were talking about the law of cosines, and we used that to solve oblique triangles, just like before. We have the capital letter A corresponding to little a, right, across. Capital B to little b, and capital C to side little c. All right, let's keep that in mind. That's going to be the same. All right. So the formula, actually, I'm going to give you what they give you on the Regents exam. They give you A over, that's little a, over sine of capital A equals, then they do little b over the sine of capital B, and then they also give you equals little c over sine of capital C. And this looks a little confusing because there's like three sides to this equation. Basically what it's trying to say is that you can use any two of these. All right, so like for example, if I take and have like two things, I can, let's bring this up to the front. Okay, I can have, I can just use this part of it. All right, where it's, if I'm talking about angle B and angle C, then I'll use that. Or it could be A and B, or it could be A and C, right? So it's going to be any two out of the three that you're actually going to use. Okay? All right. So when do we use law of sines as opposed to the law of cosines? Now, if you remember, we use law of cosines when we have side, 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 and side, angle, side. Well, law of sines is going to be used if we are given an angle, and then a side, or an angle, a side, and then an angle, and those are going to be the examples we're going to work today. Next lesson, we'll get into this third example, which is the one that was taboo in geometry class, but is okay in trig, the side-side angle. All right? All right. Procedure, just like before, draw and label a triangle, plug info into the formula, solve for what the question asks for. I don't know if you noticed, that's the same exact procedure that we would have if we were using the law of cosines. All right, so triangle ABC. A, B, C. All right, this time they tell me sine of A is 4/5. Again, I'm not going to write 4/5 there. I'm going to say sine A is 4/5. Okay, and sine B, that's this here, sine B is 3/4. And little a is 16. Again, that's across from angle A, so 16 goes there. They want me to find little b, which is this side right here. So what I'm going to do is set up a proportion when I use the law of sines. The information that I have is really angle, angle, and then this side, right? Angle, angle, side. So this would be not a case of the law of cosines, it'd be law of sines. And what I do is I take the side over the sine of the opposite angle, so sine of A. Right? It's going to equal little b over the sine of capital B. All right, and I substituted in 16 for the A, and now at this point I'm going to substitute in the 4/5 for sine of A and the 3/4 for sine of B. Please be careful, do not do the sine of 4/5. It is 4/5. And that equals b over 3/4. So now what I have to do is I have to cross multiply. Well, okay, 4/5 times b is 4/5 b. And that equals 16 times 3/4. Okay? 16 times 3/4, that's going to give you 12. Equals 4/5 b. So I multiply both sides by 5. And you get 4b equals 60. And then you divide both sides by 4. And you get b equals 1. And let's see, 1, 5, 15. There we go. Okay, example 2. Again, I have triangle ABC. ABC. And this time they actually give me the measure of angle A. They tell me angle A measures 35 degrees. And measure of angle B is 48 degrees. Little a here is 16. Okay, well that goes across from angle A. And now it wants me to find C, little c to the nearest 10. So it wants me to find this side to the nearest 10. Okay, now if I want to use the law of sines here, I obviously want to find little c. So I would like to have that in my equation. So what I'm going to need is I need to have a pair of the side and the opposite angle. So like I can do little c over the sine of big C equals, and then I know what little a is. I have no idea what little b is. So I don't think that's going to help me at all. But I do know that little a is 16 over the sine of a, which is sine of 35. So there's actually two things I need to figure out right now. Okay, I need to find out what angle C is and find little c. So before I can find that side c, I need to find the angle c. And that comes from the sum of the angles of a triangle. Have to add up to 180. 35 plus 48 plus angle C, the measure of angle C, should add up to 180. Okay, so you just take 35 plus 48, okay, and you get 83, so it's going to be 180 minus 83, and that gives me 97 for C. So C is 97 degrees, so this one's 97 degrees. So I can plug that in to my equation. C over the sine of 97 equals 16 over the sine of 35. Now when you're working with these, I would like you to keep them to accurate to four decimal places, okay? So well, let's cross multiply first. C sine 35 equals 16 sine 97. Okay, and at any point here, we can evaluate the sine of 35 degrees. Make sure your calculator's in the correct mode. We're in degrees, that's good. Okay, and I'm going to evaluate the sine of 35. Accurate to 4 decimal places, please, right? So we're going to do C times 0.5736. It's going to equal 16 times, we're going to evaluate the sine of 97. Sine 97. So accurate to 4 decimal places, that's going to be 0.9925. Now I multiply that by 16. And keep a few decimal places here as you're working, all right? Don't round too early, okay? If it wants you to find it to the nearest tenth, you need to keep at least to the nearest hundredth. You know, I just keep like 3 or 4 decimal places here so that I know I'm not going to have any real rounding errors. Okay, there we go. And then I think it's fairly obvious at this point to find C. I'm going to divide both sides by 0.5736. So I take the answer, which is still in my calculator, and I can just divide by 0.5736. And I get 27.686, right? Well, and I want this to the nearest tenth. So my answer is going to be C equals 27.7. Right, and it's a side, so it doesn't need to be labeled with degrees. Okay, next example. Find little b to the nearest tenth. Now I have 2 angles that I'm given, and I'm given another side. I'm given this side 12. If I want to use that in the law of sines, I'm going to have to know what the sine of C is. All right, well, 105 plus 23 plus C, it's going to be 180. All right, so 128 plus C equals 180. Subtract that from both sides, and you get 52. So I know angle C is 52 degrees. I think I'm ready to set up my equation. I can have, let's see, 12 over the sine of 52 is equal to, now I can do little b over the sine of 105. Sine of 105. All right, let's see, I'll put that there. There's a little room. It's going to be 12 sine 105 equals b sine 52. And again, if I'm going to evaluate sine of 105 and sine 52, I want to keep that accurate to 3 decimal places. So that's going to be 12 times 0.9659, and this is going to be b times, and I do the sine of 52 now, sine 52, I get 0.7880. Alright, and now I multiply these and divide by 0.7880. So 12 times 0.9659, enter, gives me 11.5908. And that equals 0.7880b. So I divide by 0.7880. 0.7880. Okay, and on this, that's divide by 0.7880. All right, and I've got 14.7. I didn't read the directions to the nearest tenth. Okay, so 14.7 is my B. Okay, final example here. PQR, triangle PQR. PQR. They tell me the measure of angle P is 34 degrees. Right, and the measure of angle Q is 75 degrees. And that r equals 12. Okay, again, now I've given you, we have two angles. We have an angle, side angle here, right? So we can use the law of sines to find little p to the nearest tenth. So little p is here. So obviously I'm going to want to use the 12 and the p as my sides. So it's going to be 12 over the sine of r equals p, little p, over the sine of 34. And again, I'm going to use the fact that the sum of the angles of a triangle is 180. 34 plus 75 gives me 109. You subtract that from 180. 180 minus 109 gives me 71 degrees for r. So I found that angle, and now I'm ready to go. 12 over the sine of 71 equals little p over the sine of 34. Okay, and then when I cross multiply, I get 12 sine 34 equals p sine 71. All right, and what you can do if you would like is you can now actually, before you evaluate them even, you can also do this and then kind of evaluate it all in one shot. And that would happen like this. You do 12 times the sine of 34, okay, and then I'll get a value for that, and then divided by the sine of 71, right? And every single little step doesn't have to be written out, and now I don't have to worry about rounding to the appropriate place, or rounding too early, because I haven't rounded it all yet, and I have my final answer, and I can round it wherever it says nearest tenth again. That's pretty common. So that is going to be actually 7.1 equals p, right? Because it's 7.09. All right, 7.1 equals p. All right, hopefully everything went okay. And in class, we'll be doing some practice of this, and I'll be mixing in some law of cosine questions. So you're going to have to decide, can I use law of sines or law of cosines? Okay, thank you. Good luck.